Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's presentation, we'll be talking about what is an influential point and what is a leverage point and how it impacts the regression model output. To understand more about influential point and leverage point, let me show you a picture. As you can see here, in this particular picture, I have taken time as the dependent variable and diameter as the independent variable. We have a regression line here, and you see four important points here. This is point 1, this is point 2, this is point 3, and this is point number 4. And you have a set of points lying along the line. Now, what is the importance of each of these points? And why should I care at all about point 1, 2, 3, 4? And how do each of these points affect the quality of my model? Let's talk about the first point. It is lying along the line. This point you can call as low leverage and low influence point. I repeat, it can be called as a point with low leverage and low influence. Let's look at point number 2. This has a very high y-axis value. In the y-axis, we have taken time. It is high on time, but it is normal it's a normal value corresponding to the x-axis. So when you have a very unusual y-axis value, but a normal value for x-axis, you can call this as a low leverage, high influence point. What is the message behind this? Points which are unusual for y-axis can be called as highly influential points, but low leverage points. At the other extreme, you have point number 4, which has a very high diameter value. It has a very unusual x-axis value, but a normal y-axis value. This is a point which can be called as high leverage and high influential point. So these are two very interesting points, because point number 2 is low leverage, high influence. Point number 4 is high leverage, high influence. Point number 3, which is lying along the regression line, this is a point which can be called as high leverage and low influence points. Now, each of these points make a huge impact on the regression model. We will be talking about the impact that each of these data points make on the regression model. One of the important things to understand here is, and this is just a rule of thumb, any point which has an unusual value for the y-axis, any point which has an unusual value for the y-axis can be called as an influential point. And any point which has an unusual value for x-axis can be called as a high leverage point. This is just a rule of thumb. If you want a formal definition for leverage and influential points, let me show you the next sheet. Here, I'm trying to impress upon you what is the difference between an influential point and a leverage point. An influential point is a point which, when excluded, causes major changes in the fitted regression function. So a point is considered to be influential if its exclusion causes major changes in the fitted regression function. What is the impact of an influential point on the regression output? It affects my p-value. An influential point affects my r-square. An influential point affects the model coefficients as well as an intercept term. So this is the problem with a high influential point. To understand this better, let us switch back to the original picture. You can see here, point number 2 here is a highly influential point, and point number 4 here is a highly influential point again. So point number 2 and point number 4 are dangerous points. Look at point number 3. Here we are saying it is a low influence. Look at point number 1. It is a low influential point. So we need to pay special attention to point number 2 and data point number 4 because they are highly influential points. And as you have read here, highly influential points can cause major changes in the fitted regression function because it affects the p-value, r-square. It also affects coefficients and intercept. Now let's focus on the leverage point. A data point whose x value is unusual. However, the y value follows the predicted regression line. I repeat, a data point whose x value is unusual. However, the y value follows the predicted regression line. So unusual x-axis value, that's what is being mentioned here. Now, let's look at a high leverage point here, a high leverage point here. So point number 3 and point number 4 can be called as a high leverage point. Why do we say that this is a high leverage point? Look at point number 4. The value for diameter is almost 10 units. Same goes for point number 3 as well, because the value of diameter here is again 10 units. So because point number 3 and point number 4 have a very, very unusual x-axis value as compared to its neighbors, you can call point number 3 and point number 4 as high leverage points. What is the impact that point number 3 and data point 4 have on my model? A leverage point inflates or it increases the strength of the regression relationship. Number 2, it reduces the p-value. My p-value goes down, and if the p-value goes down, it encourages rejection of the null hypothesis. Thirdly, a high leverage point increases the r-square. Fourth point, leverage points have no impact on the coefficients because the point follows the predicted regression equation. To understand point number 4, let me show you the picture again. Point number 3 may be a high leverage point, but since it is along the direction of the regression line, what we are saying is that it has no impact on the model coefficients because the point follows the predicted regression line. So point number 3, if you see, it is following the direction of the predicted regression line, and therefore it has no major impact on coefficients. To practically see what and how do we identify influential point and leverage point, I will take you to SPSS and through a small example illustrate high influence and high leverage values. This is the SPSS screen. Let me quickly open a file which is called as polishing dataset. You see different household utensils here like bowls, casserole, dish, tray, and plate which are being manufactured. The type of utensil is being mentioned here. What are certain characteristics of these items is also shown. For example, casserole. The diameter of the casserole is 10.7 units. Time is around 47 minutes, and it commands a price of $144 in the market. If you look at the second casserole, its diameter increases from 10 to 14 now. We are making a casserole which has a bigger diameter. The time taken also goes up. It exceeds 1 hour, and the price that it commands in the market is around $215. What is the sample size in this data set? The sample size is 59, which is not a very, very good sign because I need to have a healthy sample size. But since this is just a demonstration, I'll still go ahead and build a model. To build a linear regression model, I will click on Analyze, Regression, and then choose the second option, Linear. This opens up a new dialog box. One where it expects me to specify the dependent and the independent list. In the dependent list, I will choose time, and in the independent list, I will push the variable diameter. Time depends upon diameter, and therefore time is chosen as the dependent variable and diameter is chosen as the independent variable. In the first instance, I'm not taking into account the presence of influential points and the presence of leverage points. I'm running a very, very vanilla regression model. Let me click on OK. Very quickly, SPSS produces the output. It says that diameter is the variable that I've chosen as the independent variable. R square is 49%. That is, the coefficient of determination is 49%. You can see that the p-value is smaller than 0.05, indicating that the model is significant. Further, you can see here the coefficients table. We get the intercept term as minus 1.9, and the unstandardized coefficient for the variable diameter is 3.4 units, which means that as diameter increases by 1 unit, time taken to manufacture such a household utensil goes up by 3.4 units. Is that significant? Yes, it is significant, because the p-value is smaller than 0.05. I can go ahead and say that diameter is a variable which affects the model. So this is how a simple linear regression model would work. As I said, I've not taken into account the presence of influential points or leverage points. Now, let me show you how do we detect for the presence of influential points and how do we detect for the presence of leverage points. To show this, let me go back to the data editor window. I will click on Analyze menu, choose the option Regression, and the very second option here is what is called as linear. The old settings are shown here: time along the dependent variable, diameter along the independent. I'm not going to disturb this setting. What I will do is, at the right-hand side top corner, you see different tabs. I will click on the Save tab. Under the distances measure, you have 3 different distances that SPSS calculates. What is called as Mahalanobis's distance measure. Second one is the Cook's distance, and the third one is leverage values. Cook's distance is very, very useful in identifying influential data points. So what these selections do is that in the SPSS data editor window, in the SPSS data set, you can see 2 new columns being created. First corresponding to Cook's distance, and the second one corresponding to leverage values. After these selections, the rest of the things, I'm not making any changes. You can click on Continue and then say OK. It produces the output. I'm not interested in looking at the output. When I scroll to the right side, you see 2 new variables that are being created. Before this particular operation, I had data till price, new variable like Cook's distance measure and leverage is shown. You see a whole lot of numbers here. It's a bit difficult to make sense of these numbers. How do we interpret these 2 new columns? To interpret these 2 columns, what I will do is construct a scatter plot by taking Cook's distance measure along the y-axis, leverage along the x-axis. Let me click on Graphs, choose the option Chart Builder. Here, there are a lot of graphs that you can see, like bar chart, line chart, area chart. I'll choose the option Scatter Dot. Let me drag and drop the second preview here. This is what is called as the simple scatter with fit line. I have to supply a variable along the y-axis. Cook's distance measure will be taken along the y-axis. Centered leverage value will be taken along the x-axis. It gives you a preview of the regression line. What I'll do here is I can go to basic elements. Not basic elements. I'll have to click on groups /point ID. I want to name each and every ID here. name each and every data point here. So I'll choose the option which says point ID label. You can see a blue box being displayed here. Here, I'll drag and drop the variable type. You see the fifth variable here is type. I can drag and drop this particular variable type to label each and every data point. Once you make these selections, please click on OK. Now, this is the scatter plot. Very, very interesting scatter plot. As you can see here, Cook's distance is taken along the y-axis. Centered Lagrange value is taken along the x-axis. And as you can see here, most of these data points are clustered here, implying that they are not very, very harmful. I don't see an unusual x-axis value. I don't see an unusual y-axis value. But there is one very, very disturbing aspect to this, and that is here you see a data point which is labeled as tray. Now, the centered Lagrange value is very, very high. The x-axis value is very, very high, and the y-axis value is also very, very high in this case. Now, when the x-axis value is very, very high and the y-axis value is also very, very high, what do we call such a data point? To show you this, let me go back to the original chart that we have. This is the original chart. Here, it says point number 3. This point is at least lying along the regression line. It is lying along the regression line. Therefore, we called it as a high Lagrange and a high influential point. Now, when I look at the SPSS output, you see a point here. This is not lying along the regression line. It is remotely located at one place. It has a very unusual x-axis value. It also has a very, very unusual y-axis value. Therefore, this data point can be called as a high Lagrange and a high influence point. I repeat, it can be called as a high Lagrange and a high influence point. All these points are okay. I cannot call them as highly influential or high Lagrange points. They are just data points, but I cannot call them as high influential points or high Lagrange points. But this case here can be called as a high influence and a high Lagrange point. Why should I care about high influence and high Lagrange point? The simple answer to this question is high Lagrange affects the regression line, while the high influence affects the slope. I repeat, high Lagrange affects the regression line. Because this is a high Lagrange point, this affects my regression line. Secondly, because this is also a highly influential point, it affects the slope. We have seen what is the kind of impact that high influence, high Lagrange points have on the data. Let me just recap this. An influential point, particularly a highly influential point, it affects my p-value, it affects r-square, it affects the coefficient, it affects the intercept. A high Lagrange point increases the strength of the regression relationship. It reduces the p-value, it inflates r-square. So these are all certain problems that we can expect from this particular data point, which can be called as both highly influential as well as high Lagrange data point. Now the question is, how do we proceed from here? How do I take care of a highly influential and a highly Lagrange data point? To recall this point, a point with an unusual x-axis value can be called as a Lagrange point. A point with an unusual y-axis value can be called as a influential point. to further do a deep dive of influential versus leverage, let me look at the third table. One of the measures which helps me identify the influential data point is Cook's distance. Cook's distance is useful for identifying outliers in the X values. Cook's distance shows the influence of each observation on the fitted response values. What is the cutoff to decide whether a point qualifies as an influential point or not? If the Cook's distance value is greater than 0.5, if it is 0.6, 0.7, if it is close to 1, it is a cause of worry. Why? Because it needs further investigation. An influential point affects the model coefficients and the hypothesis testing results. If the Cook's distance value is bigger than 1, then such a point qualifies as a influential point. Values closer to 1 and greater than 1 is definitely a influential point. Second, leverage value. Leverage, it measures the influence that a point has on the fit of the regression. Why should I care? Because high leverage value affects the model fit. So this is how I can evaluate whether a point is an influential point or not. In the Cook's distance column, if any point is bigger than 0.5, you can call it as a influential point. Let me take you back to the SPSS data editor window. You can see two new columns here, Cook's distance and leverage. And you see a lot of values here. Our cutoff is greater than 0.5. What I will do is I will select this column, right click, and sort it based on the descending order. Why am I sorting this based on the descending order? Because all those values where the Cook's distance measure is really high will come right at the top. And once I am able to see high value for Cook's distance, I can eliminate it. Look at one particular data point here. And if I scroll to the right side, this is the data point. Here we are talking about tray. The diameter is 25 units. When I look at some of the other numbers, it is pretty high. We are talking about a tray whose diameter is 25 units, and the time taken has gone to 3 digits. It's 109, roughly 2 hours, not exactly 2 hours. To manufacture this particular tray, we are taking approximately 2 hours, and the price is also very, very high. Now, more than this, what is very, very important to me is that the Cook's distance value has shot up. Now, there are many approaches to dealing with a Cook's distance measure. One particular approach is that once you have decided that a particular value is an outlier, you have to compute the weights by specifying a weighing variable that gives the influential point less weightage. You can rebuild the model. An easier way of doing this, and since this is just a demonstration, what I'll do is I will select this influential point, right click on this and say clear. Once I clear this, you can see here the Cook's distance, which is greater than 0.5, has been eliminated. Now I will run the regression model again after taking into account the presence of influential and influential point mainly. Look at regression. I will choose linear here. The old setting will remain as it is. I will choose the option OK. As you can see here, the present R square value is 0.36. This is the present R square value after removing the tray, which was a highly influential point. It was also a leverage point. My R square value now, after dropping the influential point, is 0.36. Let me look at the earlier model summary table. It was 0.49. Now the R square value has come down to 36%. Earlier it was 49%. Look at the unstandardized coefficient value. Very, very interestingly, after eliminating the influential point, the sign of the constant term is positive now. Earlier, when you look at the intercept term, let me show you the earlier table, the sign of the intercept term was negative. Now, when I look at the present intercept term, the present intercept term is plus 3.39. Earlier, what was the intercept term? It was negative 1.9. When we had influential value, the unstandardized coefficient for diameter was 3.4. Now that I have removed the influential point, what is the coefficient for diameter? It has reduced to 2.916. To just show you and to show you what is the impact of having outlier and removing an outlier. It's not necessarily an outlier. I'm referring to influential and leverage points. I have pasted the SPSS output in my Excel sheet so that you can compare it side by side. This is the first model output. The R square that I got when I had influential and leverage points is 49%. Now, once I've removed the influential and leverage points, R square has dropped from 49% to 36%. Look at the coefficient value. When we had influential and leverage points, the intercept term was negative. Now the intercept term is positive. Secondly, when you look at the coefficient for diameter, earlier it was 3.4. Now it is 2.916. This is the kind of impact that an influential and a leverage point has on the output of regression. Now, what is the inference that I draw from this exercise? The two main points here, when I compare the two regression outputs, is that a high leverage value affects the model fit. Secondly, an influential point affects model coefficients as well as the hypothesis test results. To summarize the discussion that we had today, we spoke about the differences between an influential point and a leverage point. We also spoke about how an influential point harms my regression output. We spoke about what is the impact of the leverage point on the output. Nextly, we spoke about what is the ideal cutoff point of the Cook's distance measure to call a particular point as an influential point. Remember, if the Cook's distance value is greater than 0.5, it needs further investigation. If the Cook's distance value is bigger than 1, then it indicates the presence of an influential point. We spoke about two strategies to handle an influential point. One, you can specify a weighing variable that gives the influential point lesser weightage. Or secondly, you can identify an influential point and eliminate it. And we concluded by making a comparative study of two regression outputs, one with influential and leverage points. You saw the R square was higher, it was artificially inflated. Without influential and leverage points, we see that the R square drops. The model coefficients, the sign, everything will change when you take care of the influential and the leverage points. With this, I have come to the end of today's presentation. I hope you have benefited from this presentation. I thank you very much for watching today's presentation. I request you to subscribe to my channel and share with your friends and relatives. Thank you very much. Have a great